In this topic, we will discuss a reliability problem well known as bearing problem in a simulation and modeling course. Hi, this is Abid Khan, ID 12115168787. So let me share the scenario first. Um, Suppose a mill uh, has three milling machine has three bearing uh, that has an lifetime. So one scenario can be each bearing will be replaced whenever it is stop working, and another scenario we will uh, can be um, we will replace three bearings whenever any of the bearing stop working. So we will simulate these two scenario in various criteria. So in this simulation, we will consider these requirements like the meal estimated downtime $5 per minute, and the cost of the repair person is $15 per hour. It takes 20 minutes to change one bearing, or 40 minutes to change three bearings. Uh, all those three bearings. Each bearing cost $16 each. So let's go to the solution simulation. So there are some more conditions we have, like bearing life distribution. Here, the probability and the random digit assignment table represents these conditions, and another table represents the delay time distribution conditions. Here, the random digit column um, found from the probability and cumulative probability of these delay times column. Let's start to the math. Another table we get that random digit of a bearing 1, bearing 2, bearing 3, and the proposal means 3 at a time. This is the proposal. So all those are random digits for wheel life, and these are the random digit for the delay time. So this is our final table. Now we will get after simulation. So here is the random digit of these tables. One case, we will consider 20,000 hours of uh, this simulation. So each of the bearing we will consider uh, about 20,000, minimum 20,000 hours. So here is the random digit column found from these column, and this is random digit for bearing 2, this is random digit for bearing 3, and found the life hours columns, and this is the cumulative life hours column. Cumulative means any specific row is summation of the previous and the current life hours, and this is the random digit for the delay time, and this is delay time. So we will get this random digit for delay time means here is the random digit for delay time, and this is the delay time digit and and this is the delay time. So we will get these tables for all the bearings 1, 2, and 3, and we'll this is the summation of the delay time to to get 20,000 hours for bearing 1, and this is the delay time summation to get 20,000 hours for bearing 2, and here's the delay time column to get 20,000 hours for bearing 3. And we will get all those delay time individual bearing changes, and from this we can calculate. This is actually the representation of 20,000 what I have said in the previous slides. And actually we will calculate these calculations, like cost of bearings. Actual total 46 bearings, 16 plus 16 plus 14. This means fo- uh, 46 bearings will be changed. Each bearing costs $16, so total cost of bearing 736. And cost of delay time, actually total delay time, we will what we will get in the table, uh, 110, 125, and 95. And total delay time is here is the total delay minutes, and $5 per minute delay downtime costs $5 in the mill. So total cost of the delay time is $1,650, and total cost of downtime during repair. Uh, each individual bearing repairs requires 20 minutes, and total 46 bearing we have calculated before, and $5 per minute for each for the downtime costs 4,600 dollars. That is the downtime during repair. And the cost of repair person is 46, actually 46 bearings, 20 minutes per bearing, and 60. Here's the $15 per hour. That is $230 cost of repair person. So total cost will be summation of all these costs. That is $7,216. So we will get, if we change individually, the, those bearings individually, then the total cost will be $7,216 uh, of for the 20,000 hours support, 20,000 hours support of the machine. So um, here we will simulate if we change all the bearing, and whenever any of the bearing fails, so what will be the total cost. Here is the table. In this table, bearing 1 is the hour that we have got from this column, and bearing 2 and bearing 3 will replace placed in these columns. And finally here, if all those uh, don't will not get the summation of 20,000, we will take the next random digit, and according to the random digit we will get the delay, we will get the life hours of that specific bearing. So these three columns, after getting these three columns, we will have another column, that first failure hours. So first failure hours will be the minimum of any of these three bearing. Here in this case, one 1400 is the minimum of these three bearings. In this case, 1000 is the minimum of these three bearings. In this case, 1300 is the minimum of these three bearings. And we will write those accordingly. Accumulated life hours is the life hours, and current life hours plus the previous life hours, current life hours plus the previous life hours. For the first case, the previous life hours is 0. So here is the 1400. And in this next case, current life hours is 1000, and the previous is 1400, and the total accumulated is uh, 2400. And the process is going accordingly. So these columns are random digit for the delay time and the delay time. And random digit for the delay time, um, we will get, here is the random digit for delay time for the for these case bearings, whichever bearing we have selected, and the delay time is the delay time that we will fetch from the delay time table, uh, showed in here, showed in the problem. So according to the delay random digit, we will get the delay time, and this is the summation of the total delay time to make it 20,000 hours. uh, in this according to the proposal 2. So the here is the calculation that total cost of the bearing, actually total, we have totally changed, 80 54 bearing, uh, here 18 occasion to change. So each time we have changed 3 bearings, so total 18 into 3, total 54 bearings we have changed, and $16 to change each bearing, that cost $864. And total cost of the delay time is the summation of all delay times, and multiply with 5 minute, $5 per minute, that is 625. And total cost of downtime during repair is 18 set. Here is the 18 set, 18 times we have changed, and 40 minutes per set that we have got from the problem, 40 minutes to change 3 bearings. And finally, $5 per minute, total cost $3,600, uh, that is cost of downtime during repair. So cost of the repair person is, we have changed 16 times, 18 times, and 14 minutes per set. And now the repair person will take $15 per hour, that costs $180. So the total cost will be the summation of the all costs, that is 5,269. So according to the simulation and calculation, we have got that if we change 3 bearings at a time, that cost 5,269. And if we change bearing according to the need, according to the failure, so it will cost $7,216. So we will get that the second proposal is more efficient for the that that we have got from the simulation. Thanks. This is